Hi, I'm Deriv'era and PSP. In cold winter of 2025, when we barely had any snow in Serbia and walked outside in t-shirts, I've been planning on which YouTube video to make next, when suddenly an idea appeared of making something about PSP. I'm a short development fused person, so I've started the development immediately. I thought I can manage 5 game episodes with different level graphics and enemies in just 2 months while doing my job in parallel, when I was still employed. After 3 months, I realized that it will take me 6 months to make just 3 episodes. After 8 months, I finally released the first episode with 2 planets for the future, hopefully both appearing in 2025. My planning skill has a negative score. I released the game on itch.io in early access, mostly just to make this video and to return to YouTube, because when AI will replace me, I'm just going to become a celebrity on YouTube. And I decided to release the full game on Steam when it will be fully ready. That's at least my little strategy. Steam wishlist link will appear in the description after Steam approves me on their platform, because it takes time. What is PSP? A game console released by Sony in 2004, 21 years ago. Technological marvel of its time, with a relatively low price and the only one popular handheld in our history that is using laser discs. It was released with CPU locked to 222 MHz, and later Sony unlocked 333 mod, cause many developers ask for more performance, so it drains battery faster. It has 32 MB of RAM in the early and 64 MB in the later models. Games still use 32 MB because 64 MB were needed for Skype, dead by now. PSP has been positioned as a network device with communication capabilities because it had Wi-Fi. GPU is custom called Surface Rendering GPU. In terms of API, it is very similar to OpenGL version 2, with lack of some functionality. It's so close to OpenGL 2 that there are some libraries in existence that translate OpenGL calls into PSP GPU calls. Some tutorials use this approach instead of direct PSP GPU API. As a permanent memory, it uses Memory Stick Duo, proprietary card format from Sony, and for music it uses special Sony format, a track 3 that Sony already had been using in its music players to avoid paying for MP3 license. The CPU has floating point unit or FPU. It's important to mention this because for some reason some sources tell that it doesn't. Especially ChatGPT states lack of FPU all the time because ChatGPT is stupid shit. So from a history perspective, it's a decent piece of hardware. It is one of the most popular game consoles in our history, and players enjoyed it while ignoring a lot of Sony's bullshit. And there are a lot of bullshit in PSP. UMD discs are proprietary, so after factories stop producing them, there are simply no physical way at the moment to release your retro PSP games on physical discs. Sony claimed it has been done this way to prevent piracy, but to me it sounds like a total lie, because console supports flash cards. It was logical that at some point people will learn how to run pirated games in Homebrew from them. Memory sticks are another topic, because they were much more expensive than SD cards and died out fast. In the modern age, people just use SD card to memory stick adapters to deal with this crap. These adapters cost almost nothing and pretty convenient. PSP was as unfriendly as possible for Homebrew, and in comparison to Game Boy, it stays its ground nowadays as well, because PSP SDK that has been made by enthusiasts is not a matured piece of software. It has mistakes and confusing statements. Here, for example, SCE audio SRC SH reserve returns value described as a status. 0, no errors. Other value is an error code. But example over here in SDK uses this function to get channel number. This example works just by accident, because technically just return channel 0 to be used all the time. Some critical functions doesn't have any examples, and it's even worse. For example, SCE track decode data, and overall lack of examples on how to work with the track 3 hardware. I spent a lot of time coming up with my own solution, trying different numbers, buffers, delays, and approaches on how to make it work well. Without extensive programming and debugging skills and experience, I would say coding for PSP is painful. It's painful even with experience. It's not enough to know C language, you need to come up with creative solutions to make things work and reverse engineer the library that probably was already reverse engineered from the other sources. But again, it was created by fans, and I'm very grateful for that. In general, it works very well. There are just a couple of problems and that's all. So, why PSP? People asked me this question a lot during these 8 months. There are two types of developers, the ones who can control their urge to add as many features as possible and ones that don't. I'm of the second type. When I plan to make a small game, usually it becomes a few years project. I just think all the time that it's not good enough stripped of good stuff so much, so I need to add as many features as possible just to make it look good. But when it's restricted by hardware, I just think nothing I can do about it. I just can't squeeze more, and my scope reduces naturally, without much of my attention. Also, PSP really teaches you that every feature will take part of your soul to implement. For example, it took me around 6 entire rewrites of level rendering system just to make it look okay and somewhat fast. But we will get to programming a bit later. Second big reason someone should create content about development for retro devices. Otherwise, this part of the history may just vanish. Glimpses into games and hardware aren't enough in my opinion. When you develop games for retro consoles, it's a real glimpse into history and how it was, and it's a very special feeling to experience. We simply don't have such feelings with modern development, or maybe I'm just a masochist and I like this feeling of development pain. Third reason is marketing. I have some hope that the fact of a commercial PSP game release in 2025 will get some traction and won't go unnoticed, and understand that actually I have magical thinking. Fourth reason is PSP is modern enough for 3D games, but not modern enough for games to look modern, if it makes sense. You need to cut the game a lot to make it work, and the result will be retro in any case. And I wanted my 3D game to be called retro, not retro style. Anything you create for PSP is truly retro. Fifth reason is I just wanted to. Sometimes I just want something while I can't explain the reason. So these 5 reasons were my main driving forces to make Locom Tenants. And it's totally valid if you don't share the same feelings about it. I'm not really sure I even want other people to make PSP games. As I said, the process is unfriendly and overall Sony is not your friend. To code for PSP you will need a real console, there is no way around it. Emulator processes games very different from how they worked on the real hardware. It smoothes the experience a lot, and used PSP pieces are not that well preserved. It's 20 years old hardware after all. Mine has broken stick, even after I bought it in good condition. This is the reason why my game doesn't use stick, cause broken stick is a common problem that makes game unplayable, and well, I need to spend time to implement settings to give ability to disable stick, and I don't really want to spend time on that, but I really should in the future to make ability to use stick for movement. With this being said, let's move to graphics and real capabilities of GPU and all of the workarounds I implemented. Graphics. You start with the Polygon. Then you implement camera movement. Then you implement the rest of the game, same as with this meme all. GPU is capable to render 512 by 512 texture size maximum. It's capable to render 32-bit, 60-bit and 8-bit color textures. It also supports paletted textures. It's when the image contains indices of colors from a palette provided separately. In reality, during the development I understood midway that 16-bit color without palette is too much for 32 MB of RAM, and switch to paletted graphics, 8-bit per pixel, 256 colors per texture. I've used two formats, RGB 565 for solid surfaces like walls, and RGB 5551 for surfaces with mask like enemy sprites. Support of color formats on PSP GPU is actually very good and wide, but memory constraints just force you to use formats with the least memory impact. PSP doesn't load data fast from the flash memory, so loading even 256 on 256 PNG has lag, both for loading and decoding. Initially I tried to solve it with caching of 16-bit bitmaps in the way how they used in the GPU. Loading such processed data is faster than loading PNGs, but 512 on 512 still had a problem. It's more about reading from SD card bandwidth. Loading textures on the fly during the gameplay is not a good option. So I moved to textures with palettes because they're smaller in RAM, almost twice, so I took my old converter that makes paletted images I made for another old project and rewrote it to give out graphic files in a specific format that is easy to load. It improved loading time cause paletted images have almost 2 times less data, and with very small lag I could now load textures on the fly. So paletted textures were compact enough for me to load level graphics entirely before the level starts, and squeeze more graphics into the memory on the start of the game in general during the initial loading screen. So instead of reloading weapon textures each time you switch your weapon, that's how I did it initially, I just loaded all weapon textures into the RAM. Technically you can lazy load textures in a separate thread because PSP allows multi-threading, but how many problems it will introduce is hard to say. I just have a gut feeling that I really don't want to do parallel texture loading during the gameplay run. But in theory, if you load weapon texture during 4 frames instead of 1, you could entirely remove the loading lag. Before the rendering of a polygon, you need to set up 3 matrices that PSP will internally multiply for you. Projection matrix determines will you have perspective or not, and where will be your coordinate center. View matrix determines your camera position. Model matrix determines the position of your objects in the scene. This part is fairly conventional. Then you bin your texture, apply texture settings, and call SC-GAM draw arrays. This function just draws an array of triangles. Vertices can have different information, so you provide vertices format in the function call. For example, they may have or may have no color. With colors of vertices you can shade the texture in dark areas, for example, and overall do various effects. Last 2 parameters are pointers to the list of indices and the list of vertices. If you have experience with graphics programming, it will all feel very familiar. GPU works in parallel to CPU and it has VRAM, but it is able to grab texture information from RAM as well. From VRAM it just happens faster because GPU doesn't fight for VRAM with CPU. PSP has only 2 MB of VRAM and most of them are taken by 2 screen buffers. Still, I'm squeezing some common textures into VRAM. And now I finally came to the 2 biggest problems I had with PSP GPU. I'm using a local Git to store all the stages of game development and I commit changes often, so I can easily look into the past versions. That's how one of my first map rendering implementations looks on the emulator. Take a closer look on polygon edges, corners and other stuff. Yeah, they look clean, there are no problems. And that's how it looks on real PSP. You can see wobbling of polygon edges and black stripes between them. Why it happens? Well, my initial implementation of level rendering was very straightforward. Level has a lot of repeating structure, so I make these pieces in the RAM memory and in the map rendering phase I just pick the necessary piece, if it's visible, and put it into the rendering pipeline. Different model matrices move, scale and rotate these pieces around. PC emulator calculates vertex positions very precisely. Modern GPU is very good at matrix calculations cause it's one of the major operations in 3D graphics. So if you have several vertices that in theory should be in one place, they have different coordinates, different model matrices, but you made all of them to be placed, in theory at least, in to one place, they actually will have a slight shift because of small floating point calculation inaccuracy. This shift is so small that you don't even notice it. But on PSP, to place a vertex into the same position, you literally need to have the same model matrix for both vertices, and for all your vertices that should be placed into this point to have the same coordinates. So PSP, oh my little PSP, I'm not 100% sure where it's being lazy, cause I didn't find any information on this topic, so I can only assume that it saves some costs on how it multiplies matrices and vectors. It also might be polygon rasterization itself, the thing that fills triangles with colors. It may approximate edges of a polygon in some weird way, who the hell knows. Second problem, it is polygon disappearance, and no, it's not my engine doing this intentionally. PSP's GPU has clipping of polygons that you don't see, and it's supposed to clip polygons that are not on the screen and cut polygons that are on the screen in the way to render only the visible part. But the problem is it's not very precise on big surfaces, noticeably not very precise. To solve these 2 problems with map rendering, I spent huge amount of time and iterations, rewrote map rendering part multiple times, tried to make map smaller, for example, to hit the sweet spot of floating point calculations better, and it didn't help. help. The one before current implementation was actually good, but performance, it was very slow. And in the end, I rewrote it yet another time to get the current solution. So how does it work now? I have two temporary objects. One is rendered, second is reconstructed during the few frames in the background. I limit this reconstruction by a timer to avoid performance impacts. That's why sometimes when a lot of stuff is going on, you still can catch Polygon disappearing on the edges of the screen, but I consider current state acceptable. I have a complex and simplified pieces of each level block, like a piece of a wall or a floor cell. Different parts of the texture use different blocks because UV information is different, so the data in vertices is different as well. I use only one texture for the whole map because the texture switching impacts performance, and this big texture is loaded into VRAM for performance as well. In the end of the day, the most you render is your map. The display buffer has 16-bit color depth exactly because I needed enough space for map texture in the VRAM. 32-bit color depth for the whole screen is unreasonable, to say the least. I don't think that many games push the full color potential of PSP's display because of memory constraints. For example, in Patapon you can see pixel dithering on the sky exactly because of limited color amount. It's not just an artistic choice, it's memory management. So, back to the map. I calculate approximate visible area slightly bigger than what you see, because if you move, you will see current temporary object for some amount of frames, and it needs to be recreated according to possible movements during these frames. As a demonstration, I will reduce temporary object viewing angle so you can see what happens if angle is not wide enough while you're tuning the camera around. You can see the moments when temporary objects swap and level appears back from the void. For far stuff I use simplified objects. For closed blocks I use complex models I mentioned before. Complex models just consist of large amount of small polygons to compensate polygon cutting, and they are noticeably slower to render. If it all sounds familiar, you're right. The same technique is used for PS1 games to fix perspective issues on textures close to the edges of the screen, in games like Tomb Raider for example. Also about level creation, well, you look at one of the levels. Different colors define different stuff on the level, like walls, items and enemies. At some point I ran out of colors, so I moved enemies to the separate section of the map. When I'm editing enemies, I just move them back to the walls and items section, make some enemies, remove some enemies, and then move back and export. I load level as an image and then just interpret into a map. This way I have avoided creation of my own map editor, even if it's not very intuitive way to solve level editing problem. With time I've got used to using a sprite this way and it became somewhat comfortable. That's how the map of the same level looks in the game. Attention to details here was to create a map texture and then use polygons to bend it a little and to follow the curve of the paper. And the position of the player here follows this curve as well. And you can run around while holding the map in your hands. From the start I targeted 60 FPS, because I'm not a big fan of 30 FPS games. After PS1 I've got PC and used to playing 60 FPS games, and most of the time my implementation keeps 60 FPS per second. And FPS drops appear only when there are a lot of big sprites on the screen. That's pixel fill rate issue. Not much I can do about it. Most PSP games were made for 30 FPS, cause it's simply so much easier to make a PSP games to run on 30 FPS and you have much wider artistic freedom. At 60 FPS goal, every single bad decision kills your FPS, and it becomes really hard to create a good game. 30 FPS in general is the curse of game consoles, and it was this way since PS1 era until PS5, because picture quality sells much better than 60 FPS. So I try to limit everything, what happens during the frame to keep good performance, like the amount of enemy spawn checks game does per frame, how collision queue is built to calculate the least of the collisions possible, but make collision glitches to be invisible for player. Not all of the enemies are checked per each frame, you can see sometimes enemies appearing from thin air. Also, when you open a door, I forcefully spawn enemies near the door to make this effect less noticeable. If you know where to look, you can see it, but people who playtested the game never noticed such imperfections. Why flat levels? Well, hate adds a lot of complexity for the game development. Hate needs you to use a map editor instead of a simpler approach I took. Also, initially I wanted to create a demo, not a full game, for this PSP video, and it somehow tuned into a full-scale game during the process. Fully 3D game or even just different heights of the floor will create so much complexity in everything. It will take me twice more time to pull out something like this, with very sketchy outcome in the end. And it's my first time developing something for PSP. Shooter is a type of games that is not easy to make, even if it's such a simple shooter as mine. For top-down view or side-scrollers, you don't need to optimize graphics so much as I do to pull out good results. Even when you have a third-person view game, you're able to control camera in the way it will never get close to big polygons, so it makes it easier to solve polygon cutting problem. From huge amount of games made for these old consoles, amount of shooters on PSP or PS1 is very limited. And with only 2 shoulder buttons, you need to choose what to use them for side movement or to look up and down. Flat ground removes even the need to choose. On the other consoles of this generation and what came after, movement was solved with the usage of both sticks. But PSP has only one stick, so even here the console itself simply a really bad match for a good shooter game in terms of controls. With this being said, let's switch back to performance. Game is born to FPS to reduce the amount of calculations. It means that at 20 FPS game will be 3 times slower than at 60 FPS. Same as the most of the old games. Since FPS is born to the vertical synchronization of the display, from 60 FPS it always drops to 30 FPS or 20 FPS or lower. Frame time is always a fixed step of 1 divided by 60 of a second. Because of this, there is a hack to solve the game speed problem when it happens. When 30 FPS is detected, I double the game logic calls per frame, so on 30 FPS game works twice faster to compensate the lag. With this hack, FPS drops don't feel terrible anymore, because game speed doesn't change. During the implementation of loading screen, I found out that you can render graphics only in the main thread. Naturally, I tried to render loading screen graphics in the child thread when the main thread is doing asset loading, while it was another route to load resources in the child process and to render my funny animation in the main thread. Also, I load and unload enemies that are presented or not presented on the level to save up memory between levels, because first boss takes 6 512 by 512 textures. I want him to be loaded only for a boss fight level. I don't have any automatic unloading of textures, I just know specific cases where I can unload graphics, and I use these cases. All texture freeing and loading is used in specific situations. If there is no need to optimize something, I use the rule don't touch it if it works. As you can see, all this stuff will be hard to achieve with just a general purpose PSP engine, because a lot of hacks and optimizations are born to the game type. Write a comment if you want me to look into existing PSP engine solutions, cause they exist, and I can compare and tell some thoughts about them from the top of my experience. When you write your own engine, you know how to optimize it and what to change to achieve your goal. And PSP GPU is not a rocket science in comparison to modern GPUs with Vulkan support, for example, that require you to write shaders to render at least something, and to achieve modern level of graphics, you need to invest hundreds of hours only to get a decent modern picture with bone animation, PBR, ambient occlusion, and maybe some game-specific techniques like, I don't know, shell texturing. Anyway, let's continue with sound. Graphics implementation for PSP has a lot of tutorials. Polygons are the first thing to render after the setup of development environment. On YouTube or on websites about PSP development, it's pretty well covered topic. But sound, oh boy. PSP has 8 main channels to produce sounds that work at 44,100 Hz frequency. Frequency is fixed, you can't change it. Hardware mixes sounds and controls volume from all these channels in the background, freeing your CPU. That's the point of sound hardware, cause volume control is pretty expensive for CPU. Mono sound with 16-bit precision will take 88,200 kilobytes for 1 second. 3D space sounds are made mono cause they are positioned in 3D space to become stereo. My game has only 60 sounds plus music. 10 seconds of sounds length will take up almost 1 megabyte, so I made all the sounds as compact as possible. One channel is occupied by music. You may think that the rest 7 channels are a lot for the sounds, but they are definitely not. I have implemented systems that allows to reuse channels as much as possible. For example, by sound ID. If sound with specific ID is already playing, then the new sound will replace it and start over. It is used, for example, for weapons, for screams. Some sounds can't be seamlessly replaced mid-air, usually it's sounds that are in 3D space, because you can't seamlessly replace high volume close sound with low volume far sound. With all this information, I'm still missing something on how to set up sounds properly. Because for example, when I play the sound with the ID, then interrupt it and play the same sound from the start, it misses a small fragment of a sound in the initial position, but only when you interrupt it in the right moment. There was only one particular sound at which I was able to hear that, repeated shooting sound or auto pistol. So I literally moved shooting sound forward in Audacity 100 milliseconds forward just for the right part to be heard when the sound is repeating, cause the repeated play length is very short on this weapon. From the code perspective, everything should be fine. I checked the code many times. I'm restarting from the position 0 and it feels like the first buffer in the queue just doesn't play in specific scenarios. I spent time to make it work okay, just for player not to notice imperfections and stop debugging because it's a massive rabbit hole. And it's not the first time I'm implementing sound, but the first time to have these problems. Similar stuff happens to music. When I initially set up a track 3 decoder before playing the first track in the main menu, it fills sound buffers with junk. So I need to skip few buffers at the start of the first track before I actually can let player hear the music. Why the hell it fills these buffers with junk, I have no idea. As I understand, many modern PSP game developers just choose the path with MP3s because it's much easier, even if it's slightly harder on CPU. So back to 7 channels of general game sound. There was an option just not to play sounds if all the channels are occupied, but I went with the different solution. I made 6 channels to work in a common way, and inside 7th channel I made a software mixer. Mixer has its own sound queue for 6 sound. It mixes them in the code on CPU and then sends the result into the channel 7. But when the sound is stereo, I mean when it has different sound volume on left and right, I need to do a lot of multiplications and divisions. So this part is definitely not the fastest, but it boosts the amount of sound channels from 7 to 12. And you can hear this when a lot of stuff happens on the screen. PSP has 9th special channel with varying sound frequency. I tried to use it for the mixer in general for the game, but I wasn't able to set up double buffer to switch generated sounds between 2 buffers smoothly. It worked, but not very well. I didn't find how to use this channel reliably, so I just didn't. This channel uses exactly the function I mentioned in the start of the video about functions that return the status instead of number of channels. Initially I wanted to reduce sound quality just to free up some RAM. Software mixer working with 9th channel is the only way to do so. I'm not really sure what exactly I have been doing wrong. And searching for this information is not an easy task because it comes from such depths of PSP that even Satan fears them. So I just abandoned this idea and didn't use channel 9. Collisions. I have a feeling that each one of my videos touch collisions in one way or another, and I repeat the same things over and over again, cause nothing changes on this topic from game to game. Locum tenens collision logic happens in 2D. As part of the optimization, I removed the up axis from the collision calculation. Sphere-to-sphere collision is calculated by distance between 2 spheres and their radiuses. If penetration happens, I am using normal in the direction from A to B to move objects back on the penetration distance according to their masses. Enemies and the player are using spheres for collisions, so spheres are the only dynamic objects on the level. I've implemented masses on the late stage of game development because until boss I thought like why to implement even masses if all objects are of similar sizes, similar weights, but then I was able to push 20 tons boss around the level because masses was equal, so I implemented masses. Box to sphere is also easy to calculate. You need to get the closest point on the box to sphere center. Then it's the same calculation of penetration distance and the normal direction. I had a funny bug when I forgot to give inverted mass to the player and enemy started to push me so hard I started to fall through the walls. And the last one is sphere versus triangle, because diagonal walls are essentially triangles in 2D space. To check if sphere has penetrated triangle, first I check corners of triangle to penetrate sphere and then I check the edges of the triangle for the same thing. It's basically the heaviest check in collisions domain. And here I need to tell you some truths, that collision objects and map has different collision routines. What I mean is map does not exist in the general collision system. It's made this way so I can optimize the amount of checks between collision entities specifically for the map, because it's very different from other collisions. Raycasting is important as well because You need to know where your bullets hit. Again, map has its own routine that checks collision in specific area of the raycast using segment against box and segment against triangle collisions. Segment versus box intersection is fairly easy, you just check segment versus segment on 4 sides of the box. Segment versus segment collision checks intersection of the lines and then checks is this intersection lays on the segment because lines are infinite and segments are not. For segment versus sphere, you need to project the center of the sphere point onto the segment and you guessed it right, check the distance between this point and sphere center against the radius of the sphere. Artificial intelligence. AI of enemies is fairly simple state machines. They walk to the point, then cast a ray to check if they can hit the player, stop for a moment to give player a small window to kill them. This delay just feels nice to have. And then shoot. AI have different parameters that allow enemy to perform different actions like search for bodies, or attack the player, or spawn other enemies, or move around. The first iteration of the game art had pixel art style. I made an A-sprite. I tried to draw textures this way just to have a look on how it feels, and I understood fast that I completely dislike the visuals, so some people said that they look nice. Currently I think it might have given more interesting style, I just needed to practice for 1 or 200 hours in pixel art to find the right sweet spot. But I decided to just switch to Blender and make all graphics in 3D and then render it to images I can use in the game. Since the screen and textures are low res, I have no need to make extensive high detail models. Usually I spend from 2 to 3 days to make one character from scratch. As you can see, there were a lot of closing options. I didn't come up with this final design immediately. Maybe it was even more than 3 days because, well, first enemy happened months ago. My memory is not that precise, but in general, when I have the understanding of what I'm going to create, it takes 2 to 3 days for such model with Polygon, modeling and bones. For static objects, of course, it's like less than a day. Also, 3D allowed me to reuse assets for 3D scenes, and I have no idea how much time it will take me to draw cutscenes images traditionally. The important part of the process is also the color conversion, to have just 256 colors in a palette. I said earlier that I wrote a tool that extracts 256 closest colors from the image and creates palette out of it. Well, it doesn't work very well. More terrible than well. So if you load an image to a sprite, you can create 256 colors palette there from the image and switch to image mode to indexed, and after that you will essentially have much better results than my tool. And by using my tool after this, I just convert the image to my own format when it already has no need to change something in the PNG file because it has 256 colors. Game design. I know there are people who make games and are watching this channel, so you might be interested in my approach on game design and how I directed development. First of all, I rarely make my project's ideas entirely from scratch. In my backlog, I have only one fully original idea that is very niche, and I'm not sure I will ever even make it, even if I want to, because having an idea and having a full game description document with all mechanics and understanding of how your idea must work are two completely different things. Game design is a skill that you can learn in some schools, both online and offline, probably on YouTube, and it makes sense because there are tons of information and experience behind it. I make it easier for myself just by adding and enhancing existing ideas, cutting off stuff I don't like from existing games, and improving them on other parts. So this game is based on a shooter from my childhood, Zero Tolerance. Before I started to make the game, I played ZT from the start to end and wrote down what I like and what I dislike, what are the core components and what I can add. That's actually a common game design practice to break existing games on building blocks, to understand how do they work and how do they entertain player and keep their attention. I kept elevators but removed stairs because ZT has all the graphics available on the cartridge all the time and I need to store graphics in RAM and load it on the fly, so I decided to make no return to previous levels and added a short loading screen. I rarely use the ability to return to previous levels anyway, and it is easier to control balance of weapons when player can't go, for example, to the boss room and get all of these shotguns because boss room has a lot of shotguns. More than user needs, just in case for boss to be beatable for sure and to trick player a bit, giving his attention from something more important, but I won't spoiler. In a shooter game it must be satisfying to kill enemies. General rule, Don't make them very bulky. Make them easy to kill or with interesting behavior. And you should be able to feel progression of killing with better weapons, because progression is important. One of the key features in Zero Tolerance is that power of your weapon depends on the distance. Better the weapon, longer the distance, it saves full damage. Laser rifle, one of the last weapons, for example, can one shot from any distance. I used the same idea. Balance of weapons is very important, not because your game should have different weapons, but because your weapons is a tool to kill enemies. That is the main goal of your shooter game. And progression through weapons stops the player from getting bored because of the limited core gameplay. Progression, different enemies, different situations, visuals, explosions, atmosphere, music, maps, everything I've done is trying to support the main pillar of killing the enemies, because it's fun. And the way how you achieve this goal is what differentiates your game from other shooters. And did I succeed or not is for you to judge. Another important aspect in my opinion is interaction of objects with each other. Parasites in my game can take corpses. Interaction between enemies and objects makes world much more believable. Blood on the walls that slowly go down, another aspect of interaction between world entities. Breaking of walls, same as it was in Zero Tolerance, supports this depth feeling of the gameplay. Doom, for example, allowed enemies to kill each other, but I decided not to take this route. But this is also an example of world simulating its own life. About difficulty, I'm using my gut feelings here. I make a game difficult to play for myself and then reduce the difficulty by adding some items here and there, so for players who has less experience in such games to have better odds on completing the game. I understand that I played this game fully more than 10 times, surely. I'm playing it well. Playtester, under my observation but without my help, died 2 times. So I think the balance currently is okay. As a way on how to entertain player, each level should provide something new. It's probably the easiest game design formula to implement. Zero Tolerance follows this as well, more or less. It might be new enemies, it might be new items and weapons and new wall textures. Player needs to have this promise of finding something new to have interest to continue. I break this promise on one level, but I made it intentionally shorter and simpler than other levels, just to prepare for a boss fight. Making all levels difficult is a bad game design decision. I don't think that constant difficulty progression is a good thing. It should have some level of fluctuation. So if you break the rule of novelty, think of what can you do different to at least not to bother player with repetitiveness. And if you wish to hear a word about time planning and game planning, I'm awful with planning, so there will be no advice. I'm using Trello and I just go through tasks and in the list and sort them from time to time. I have separate list of ideas that I may be implementing in the future. And I have a list of general ideas I won't implement, but for them to be visible, and a list of done tasks that I clear every week. For time management, I'm using a mobile app called Boosted on my phone. It basically tracks time you spend on something. I try to spend for around 5 hours a day, 25 hours a week, sometimes more on the game development. It's pure development time, so it's comparable to 40 hours working week. So far I tracked 400 hours for this game. I didn't start to track immediately after the start of the development, so there's slightly more, maybe close to 500 working hours. And because I like to procrastinate by making handheld consoles, some chemical labs for PCB making, neural networks from scratch without any leaps, DOS with VAS graphics out of all things, game engines, and getting myself dirty on the rainy days in the mountains, game development takes longer than it should. Afterthought. I've created this video for entertainment, and I hope you feel entertained. If you want a separate video on PSP programming as a tutorial with more depth than this video, just drop a comment. I just personally think not many people are interested in this. So was PSP game development worth it? I think yes. I've created something that is working. Something that is out there fully playable for 20 years old game console. That's a feeling you actually can't get somewhere else. Satisfaction that comes with the release after 8 months of development, when you made it through all the problems. It's like you were moving a huge boulder to the top of the hill and half of the way now passed, cause I still need to make episode 2 and episode 3. And during this development my thoughts on PSP have changed. I was more on the side of PSP at the start of development, if it even makes sense. It's a device, it's not a person. I mean, I more loved the things and was annoyed. Currently I just don't feel treated well by Sony, with so much proprietary stuff over here and general development and unfriendliness. And even SDK as it was provided not by Sony, but by great people who worked on it in their free time. They're really great. And during these 8 months, the state of the world, the state of gaming industry actually also changed a lot. Just 8 months. Google recently announced that they will block installation of applications that are not properly signed on Android. In other words, Android from open platform with extensive user tracking and advertisement tuned into a closed platform with extensive user tracking and advertisement. What the fuck? Major brands like Nintendo now sell shovels instead of game consoles. Sony don't release portable game consoles at all. When PSP was a truly portable device, but UMD disk are proprietary trash, a Track 3 converters, and overall software to work with a Track 3 is hard even to find, and no one will promise on how long this will even work on modern operating system. And SDK needs polishing. Just a bit more polishing and it will be okay. Someone just need to work on it to make it better. PSP left some sad feelings in me. I just want a console like PSP with better screen, open platform, ability to make your own physical media for it, well-made polished SDK, and I will be personally happy with such device, especially the form factor. I want community around this thing to be alive. Not like with unburning emulators, because like they have community of emulation, not community of game consoles. There are a lot of Android emulator devices out there, and I thought maybe community at some point will choose one of them to concentrate some effort with it to make new games or port existing games to it, you know, community of developers who make games for this console. There are some Linux-based ARM game consoles, but I never heard lately someone cared about them. Back in the days there was one, Dingo A320. It had considerable community and it was the point. Community. Emulator devices don't build community around them from people who want to create games, port games and play these ported games on them. There are some, but they are not of the level of PSP. But Dingo never evolved further. Sadly, it was a truly open portable platform running Linux. And Playdate, I know I need to mention it. The only one community-driven modern platform that worth developing exclusives for nowadays, in my opinion. The only one I hear about from time to time at least. And people are really able to earn from games released for it. Want it or not, but on free games you won't move too far. Because good games need a lot of development time and people should get paid. I'm not considering Steam Deck because it's basically a pocket desktop. Make a desktop game and you will have it on Steam Deck. On the bright side, I'm still working on my game console, so maybe I will just shake the market with super cheap, affordable open source development platform, who knows. Currently, it looks like something from Fallout or USSR and not very promising if think about it. Like and subscribe if you want more. Thank you for watching.